All right, well, welcome everybody to track 1, session 2, which is genetic testing to test or not to test. I am Carly Siskind. I'm a genetic counselor at Stanford, and I have been working with the CMT community since about 2004. And for those of you who were in the last session with Dr. Shai, I worked with him in 2004 I was hired as a research assistant in the CMT clinic. And then I went to grad school, and when I graduated, I came right back to the CMT clinic. And so I worked with him in Detroit for about 4 years, doing almost exclusively CMT. And then I came to Stanford. I've been at Stanford for 10 years now, and I still see CMT, but I also see a whole bunch of other things. But CMT is my love, and I always come back to it. And so I'm very happy to be here and happy to be with all of you. And I wanted to also recognize that, of course, I have a frog in my throat of this morning of all times. I want to recognize that Stanford sits on the ancestral land of the Muwekma Ohlone tribe. And this land was and continues to be of great importance to the Ohlone people. And consistent with our values of community and inclusion, we have a responsibility to acknowledge, honor, and make visible the university's relationship to Native peoples. And for all of you who are here, you are here supposedly because you are newly diagnosed with CMT. And I want to give you the biggest welcome and say hello, and you are part of the community, and we are so happy to have you here. For a lot of people, it becomes a long journey of finding this diagnosis, and many people have never met anyone else who has CMT. And here are your people. Welcome to the tribe. I am also making this one a little bit more interactive compared to other talks. So this is for fun, and if it's too much, then don't do it. So for example, if you're watching this conference on your phone and it'll be too much to switch to a messaging app, and then don't participate. You can put comments into the chat, although that will have your name on it versus the poll everywhere is anonymous. And so you can put in you open up your messaging app, and where you would put a phone number, put 22333. And in the message body, like where you would say, "Hi, Carly," type in Carly Siskind 826, CarlySiskind 826, no spaces, and then press enter, and you should be entered into the room. Alternatively, if you're on a web browser, you can also do it through that, which is polev.com/CarlySiskind826. And if your hands don't work so well because of your CMT and this isn't going to work for you, then feel free to leave me an angry emoji in the chat, and I apologize. This is just for fun. And so we'll start off with one word. How would you describe your experience with CMT or with the CMT community? And this could be something negative, this could be something positive. Type into your poll everywhere one word that you think shows what your interaction has been like with CMT. And I will also say that if you have more than one word, then you should put a hyphen in it, because it will not show up in this word cloud unless it is multiple things. And I'm seeing actually a lot of words here that I thought that I would see. Character building, limitations, frustrating, helpful, love, family, groundbreaking, challenging. Helpful got really big right now, which means a bunch of you have said that. And I guess is that is being part of the community. And I think that, there's so much that goes into having CMT, and it can be really challenging to go through life with having different abilities, and having your people can sometimes help with making your way through it. So I'm seeing both some of these frustrating, challenging, but also the helpful, the character building, the love. And I think all of that is okay in each person. So thank you for participating in that welcome and ice breaking. And so I'm going to continue on to talk a little bit more about genetics and inheritance and genetic testing and pros and cons of testing. And I have another poll everywhere here that is, have you ever seen a genetic counselor for your or your family member's CMT? So A is yes, and B is no. I'll give you a couple of seconds here to put in your A's or B's. My thought before I did this was that it was going to probably end up being about 50-50. And right now we're at about 2/3 have seen a genetic counselor, and a third, I'm speaking too fast. So that, but guess is probably, I'm hoping you're all seeing these results also, but yeah, it looks like the majority of people have seen a genetic counselor, which is great. So hopefully what I'm doing today then might be quite a bit of review and just will add to your knowledge base for your CMT. You can stop adding in your answers here because I'm going to go on. It's going to end up at 50-50. I love this. Okay. So Dr. Scheig showed the umbrella of CMT, and I actually, I had made that slide probably like a decade or more ago, and I love that he is still using it, and it'll come back into my talk again today also. But I wanted to kind of pull back in a lot of the things that he was talking about and give them a different context in terms of the way that I talk about CMT and the way that I think about the whole thing. So CMT is defined as an inherited peripheral neuropathy. So inherited means that it is something that is caused by genetics and has the ability to be passed on from generation to generation. Versus peripheral neuropathy basically means there's a problem with the nerves. And I really spent too much time looking for a cartoon that showed a nerve getting on a nerve of a nerve, but that was what I came up with. But the point of this is that in order to have CMT, you need to have both these things. You need to have a problem with the nerve, as opposed, for example, to the muscle, and you need to have a genetic cause. So let's start then again with some of the thoughts about neuropathy. And Dr. Scheig talked about this too, about the myelin and the axon, and he talked about the nerve conduction studies. And I'm not going to show you a picture of the nerve conduction study because that's just too much. But in general, the idea is that there is a part of the, that we compare a nerve to a wire, because most people have actually seen a wire, whereas most people have not seen a nerve. And that in the inside of a nerve, of a wire, there is a conducting metal, and a signal gets sent down through it. And then there's insulation that wraps around it, the plastic or the rubber, that protects that signal and allows it to be sent properly. So the same thing is true with the nerve, that middle piece is the axon. The signal gets sent down through the axon. And then the myelin is this green stuff that wraps around it and protects the axon and allows the signal to be sent properly. When there's a problem with the myelin, that shows up as a slow nerve conduction study. And people are said to have a demyelinating form of neuropathy, and they have a CMT in general type 1. Versus when the size of the wave, like the amplitude, the way I usually think about it is the strength of the signal is reduced, but the speed of the signal is okay, then that's a problem with the axon. It's axonal neuropathy, and that is a CMT type 2. So without doing genetic testing, you can get a general category of where you fall in just by getting a nerve conduction study, and you can be told you have a CMT type 1 or a CMT type 2. So have you or your loved one ever had genetic testing for CMT? This might be a family member. This might be, you. I'm getting about 70% at this point or have had genetic testing. About 30% have not. And this actually doesn't surprise me either. I figured that there would be probably people who had genetic testing who wanted to come in and see what I had to say, because they also perhaps had genetic testing that was uninformative or that found variants of uncertain significance and they didn't know what to do with it. So I'm going to take a little bit of time and talk through some of those, but let me start with genetics. And I'm going to talk about first, like big picture, which are chromosomes. And before I get too much into this, I just want to make a comment about some of what I will be discussing at the end of the slide, which are the sex chromosomes, which are the XX and the XY. And these are, I'm going to be referring to people's genetic or chromosomal sex, but this does not necessarily reflect somebody's gender, and it may not be inclusive of the intersex community. So I will be referring to XX as female and XY as male, but I recognize that this does not cover everybody as individuals. So you can see in this picture that there are all of these big lines, which are chromosomes, and we typically have 46 chromosomes in nearly every cell in the body. And our chromosomes contain all of the information our body needs in order to grow and develop and function. And they can be arranged based on their size in these black and white stripes into pairs, so that we have 23 pairs of chromosomes. And we get one member of each chromosome pair from the egg and the other member of each chromosome pair from the sperm. Likewise, when we have kids, we pass along one member of each chromosome pair, and our partner passes along the other member of the chromosome pair. The first 22 sets of chromosomes are the same in males and females. They have the same information, they have the same genes. The only place that we differ is in the last set, which are the sex chromosomes. So females have 2 X chromosomes and males have an X and a Y chromosome. Our genes are found along our chromosomes. So while we have 23 pairs of chromosome, we have 20,000 genes. So they're quite small and they're arranged all along. And just like we have 2 of every chromosome, we have 2 of every gene. So here's my little blow up. So here's 2 chromosomes, one from the egg and one from the sperm. And on the chromosome are the genes. So a gene from the egg and a gene from the sperm. Genes are made up of DNA, which is basically just a code. It's a series of letters that, when it's spelled correctly, allow a gene to perform its function. Problems can happen when there is a spelling difference in this code. So like if a T was a C, or a couple were missing, or a couple were added in. Anything that changes the spelling of the code can make that gene not work properly. When they're doing genetic testing, that's what they're doing, is they're going through and they're looking at the sequence of the letters of the genetic code and seeing if they are all in the order that is expected, or if there are any differences from what is expected. They are also looking for large chunks that are missing or extra. And the best example of this is for people who have CMT1A or have HNPP, both of which are caused by copy number variants of the whole gene, so that people who have CMT1A have a whole extra copy of the PMP22 gene on one copy of their chromosome. And people who have HNPP are missing one of the copies, so that they only have one copy of the PMP22 gene. So a bunch of you said that you have had genetic testing. How many of you actually know the gene that is responsible for your or your loved one's condition? Or are you not sure because you got some funky results and you don't know what to do with them? And I think there was at least one question in the last session about not sure what these results actually mean. I'm getting no not sures. I am shocked that I'm getting no not. Thank you, whomever it is that just said you're not sure. Thank you. I feel like that's why I'm here, is to help with those not sures. For those of you who have an answer, you are lucky in a sense to know this information, but it's actually quite common to not know the answer. So I made a comment about getting a type 1 or a type 2 based on the nerve conductions. And that's the part here on the right with the nerve problem. But the genetics provided 2 additional parts of information for CMT type. And so the first is the gene, and the second is the inheritance pattern. And what I want to start off by saying is that right now there have been about 100 genes that have been found to cause CMT. And I do think that, well, let me back up. So about 2/3 of people who have CMT have a genetic cause that is identifiable. So 1/3 of the time, people who have genetic testing, who test everything under the sun, will not get a diagnosis. And I will tell you from my experience that the people who are the least likely to get a diagnosis are people who are over 40 when their symptoms began and have an axonal form of CMT and probably no family history, but I also see a hard time for that with people with family history. And so I think that the number that's been tossed around is another 100 genes that are going to have to be found before everybody with CMT actually gets a genetic diagnosis. And that might take another decade for that to come up with. And even having genes found within the community doesn't mean that it is absolutely the answer. So there's quite a bit of work that's being done to figure out if genes that have been reported to cause CMT actually cause CMT. And that's kind of what I'm getting towards at the bottom of this here, which is that ClinGen is a group of ClinGen's a company, but they have pulled together a group of experts on CMT and said, here's the list of the genes that have been identified as causing CMT. Which of these actually cause CMT? And so far, the group has gone through 23 of these genes, and they found that 15 of them, they agree, definitely cause it. But there's at least one that absolutely does not. And so having groups like this that go through and curate and figure out whether or not genes are associated with CMT is going to be important in the future, because people might end up losing diagnoses if they find out that this gene is not actually associated with CMT. But still today, I mean, Dr. Shai showed a bunch of flowcharts about the way that we used to think about doing genetic testing, which has kind of changed with the advent of newer technologies. But what is true then is true now. If someone is going to be found to have a genetic cause of CMT, the most likely scenario is it's going to be one of 4 genes. It's going to be, this is in order of most common to least common of the 5 most common. So CMT1A is the most common cause of CMT and is caused by a duplication of the PMP22 gene. CMT1X is caused by a mutation in the GJB1 and accounts for about 10 to 13% of people with CMT, as does CMT1B, which is caused by mutations in the MPZ gene. And CMT2A is caused by mutations in the MFN2 gene, and that one's a little bit less than 10% of people with CMT who have a genetic diagnosis. And then about 5% of people are found to have HNPP with a deletion of the PMP22 gene. If you're going to get genetic testing, this is the most likely thing that will show up, even though there's 100 genes that have been associated with CMT. Taking a break from genes for a minute, I wanted to see how many of you know actually what the inheritance pattern is in your family, how this condition is being passed on. Is it passed on in a dominant, recessive, X-linked, mitochondrial way, or do you have no idea what I am talking about? Oh, thank you. And I think that these are such great answers. Thank you for saying what you're talking about, lady, because I'm hoping by the end of this that it will be a little bit more clear. So focusing in on just the genes, let's talk about the major inheritance patterns in CMT. So the most common pattern in North America is autosomal dominant inheritance. Autosomal just means that it is something that is the same in males and females. There's no difference in terms of severity or the way that things are passed on from generation to generation. Recessive inheritance is also found in about 5% of people in North America. And so starting with dominant inheritance, all it takes is having a mutation in one copy of the gene in order to be affected. So if it was in this copy of the code, it would be one copy of the gene is not working. And it's like if you have a bicycle with 2 wheels and you remove the back wheel, you're not going anywhere. So, okay, my picture has the back wheel there, but not a front wheel, but you get the point. You're not going anywhere. And I don't need any smart aleck remarks about being able to pop a wheelie and get around like that. You're in the snow, you're not going anywhere. So, dominant inheritance. One copy of the gene is working, that wheel is there. One copy of the gene is not working, it's missing. Not the gene is missing, but the wheel is missing. Anyway, okay, so this red bar means that a person has a mutation at this point. The way this is passed on in families is that the other parent presumably has 2 copies of the gene that work just fine. You recall from my picture of the chromosomes, I said that in every pregnancy, you pass on one copy of your chromosome and your partner passes on the other. It means that there end up being 4 different ways that these combination of genes can be passed on. And it ends up being a 50-50 chance of passing on the condition or not passing on the condition. So if somebody inherits the mutation, they will have CMT and they will be expected to have symptoms, although we can't necessarily say how severe those symptoms may be. And they would have that same chance of passing it on in the future, the same 50-50 chance. Versus if a person does not inherit the CMT, they will not be affected and cannot pass it on. It stops. This is dominant inheritance. This is different from recessive inheritance, which I'm going to go to now. Most people in North America will have dominant inheritance. And so you should think about this if you know nothing else. But here we go, recessive inheritance. In recessive inheritance, a person needs to have a mutation in both copies of the gene in order to be affected. So if they have a mutation in just one copy of the gene, they have a backup copy that's working just fine and provides enough protein for the body in order to not have any symptoms of CMT. So this would be a carrier. Carriers do not have any signs, any symptoms, any problems associated with CMT. It's only a person who has mutation in both copies of the gene that ends up being affected. So it's kind of like if you think about a 2-slotted toaster, and if you have 2 slots that are working, then you're going to make toast. If you have 1 slot that is working, you're going to have toast. But if both slots are not working, there's no toast. For a person who's affected with the recessive condition, so, has no toast, they have a mutation again in both copies of the gene, and then they have 2 copies of the gene. Their partner would have 2 copies of the gene, presumably, that don't have mutations in it. And if this is the case, then the affected parent is going to pass on 1 copy of the gene in each pregnancy, but the unaffected parent will pass on a copy of the gene in each pregnancy that is working just fine. And that is enough in order for a person to not show any signs or any symptoms or any issues because they are carriers. They are making toast. It's a little different if the other parent is a carrier for the same condition. It has to be a mutation in the same gene, in which case that person could pass down and ends up being a 50-50 chance of having a child that's affected, a 50-50 chance of having a child that's a carrier. These risks can be clarified by doing carrier testing prior to pregnancy if this is a concern for families. Going on to the X-linked inheritance, which is actually the second most common form of inheritance in the United States or in North America. So this is when we are calling on the X chromosome and the Y chromosome, so that, again, females have 2 X chromosomes and males have an X and a Y. And if the gene is located on the X chromosome, as is the case, for example, for CMT1X, then the females have 2 copies of this gene, and males, though, only have 1. So if there's a mutation in the gene, the male who has a mutation in the gene will then be expected to have symptoms, versus a female probably will also have symptoms, but because there's a backup copy, she usually has fewer symptoms or less severe symptoms than the affected males in the family. And it also looks different in the way that is passed on in families. So if females have 2 X's, and this is the mutation here on the X chromosome, and then again, males have an X and a Y. In every pregnancy, mom has to pass on 1 or other of the X chromosomes. But dad can pass on an X chromosome, and every time he does so, he's going to have a female child, versus if he passes on the Y chromosome, he will have a male child. And it ends up being then 4 different possible outcomes for a female who is affected with CMT1, an X-linked form of CMT. She could have an unaffected female daughter, an unaffected male son, a affected female daughter, or affected male son. For a male who is affected with a X-linked condition, it is a little different because, again, he is going to pass on his X to all of his daughters. He's going to pass on his Y to all of his sons. And so this is going to then mean that all of his daughters will be affected and none of his sons will be affected. Again, females we would expect to have fewer symptoms and be less severe than the males in the family, but they usually do have symptoms that are associated with CMT. So I want to come back to the slide, which is the same one Dr. Schei's slide showed, and it's really putting it all together. So genetic testing is important to give all the details about the genetic subtype that a person may have. So I mentioned the demyelinating and the axonal things in the beginning. And really, I kind of grouped those into type 1 and type 2. But that is only kind of partially part of the story. A person who has demyelinating conductions and has a dominant form of inheritance is said to have a type 1. They have an axonal conductions and a dominant inheritance. They have type 2. But if the gene is found on the X chromosome, then they have an X-linked type of CMT. And if it's a recessive inheritance, it doesn't matter what the conductions are. They're going to have a CMT type 4. So the categories become a little bit more nuanced when you start adding an inheritance pattern. And you don't get a subtype like the CMT1A or the CMT2F until you do genetic testing and have a positive result. And because the subtypes of CMT are defined by whichever gene it is that is causing it. So for example, people who have a PMP22 duplication all have CMT1A. Everyone who has two SH3TC2 mutations has CMT4C. And those are the definitions. You have to have the gene answer to get that CMT type. So if you want to know what your subtype is, you need to do genetic testing, or someone in your family needs to do genetic testing. But the point of this presentation was to talk about to test or not to test. So let me talk for a minute about what happens in genetic testing and the possible outcomes. So I had kind of gone through this earlier where I mentioned that the lab will go through and will read both copies of the code for all the genes that are requested. And the genes that are requested depends a lot on what's going on with you in terms of your presentation, your family history, as well as the ordering provider. So that, for example, you may just have one gene that is ordered because that is what is known to be causing CMT in your family. So why look elsewhere? Or you may have a big panel of genes that are looked at. Maybe you're looking at 70 to 100 genes that are associated with hereditary neuropathies. Or perhaps you're moving on to exome or genome testing, either as a first line or as nothing was found on a panel testing, so I want to look further. But in all of these cases, there end up being 3 possible results that can come from it. I'll say though, I wasn't planning on talking a lot more about exome or genome testing, but if that was something that people had questions about, I'm happy to talk more about it during the question and answer part. So testing results. There are 3 possible testing results that can come from genetic testing. And the first is positive, that there's an answer. Here's the kind of CMT that you have. Here's what to expect in the future. Here's the inheritance that happens in your family. Here's the other people who may be at risk. And here's whatever research may be going on within that particular genetic subtype. It could be negative. And again, 1/3 of people will have negative testing results. And in that case, depending on what testing was performed in the past, it may be that that's the end of the story. For example, if you've had exome or genome testing, probably not doing additional testing, versus if you had a negative panel test, then perhaps you are going on and having more testing depending on how you feel about things. And finally, there's these variants of uncertain significance, which are differences in the DNA code from what is expected, but it's unknown if it's actually disease-causing or just part of normal human variation. And these happen all the time. So if I send a panel of 100 genes, I will often get back 5 variants of uncertain significance. And sometimes these can be clarified, like if you have a huge family history of something and everybody in the family has the same variant of uncertain significance and those people who are unaffected don't have it, probably can be reclassified as something that is actually disease-causing. But often that is not the case, and most of the time variants of uncertain significance get downgraded to a benign variant. And I recently heard someone describe this as innocent until proven guilty. We're probably not thinking that this is the right answer unless we get more information. But that really will depend upon your genetics provider and your particular form of CMT. I'll tell you, like, the most common variant of uncertain significance that I get is a single variant of uncertain significance in a recessive gene. And when I see that, it is nothing, because recessive, again, is the one with the no toast. You need to have a mutation of both genes in order to be affected. And if there's only a single variant of uncertain significance, that is not sufficient to actually be causing anything. So why do genetic testing? Well, as I mentioned, the only way to get that specific subtype is by doing the testing and getting that gene that is associated with the condition. It can also help identify family members who are at risk for CMT, and it can potentially offer access to treatment trials or to clinical research. And if there ends up being FDA approval of any drugs that are associated with a specific genetic subtype, you will need to have personal genetic testing saying that. So even like if you have a family history of CMT1A and you never got the testing because it's obviously that you have CMT1A, my guess is that by the time the drug, the FDA approves it, and then the insurance companies are starting to say yes or no to the drug and approving it for you, you will need to have your own genetic testing that says your name and says that you are positive for insurance purposes. I kind of talked about community at the very beginning of this, and I still actually think in my mind that it's the best reason to do genetic testing. I can't tell you the number of times I have walked into a support group meeting, and the first thing that people do is they go around, they say, "Hi, I'm Carly, I have CMT1A, I have CMT1X, I have CMT2A," and they go through and they say what kind of CMT they have. And being one of the people, and there's always these people who don't have a genetic diagnosis, can feel somewhat like being on the outside. And so having a genetic answer can help someone feel like they're a little bit more part of the community. It is, I will say, a ridiculous feeling to feel like you're on the outside when a third of people don't have an answer, but I also acknowledge that it is a real thing. And finally, I want to spend a few minutes talking about family planning, because if you know a mutation that's happening in your family and you are concerned about passing it on, then there are things that can be done. I bring up specifically if you are concerned about passing it on, because some people will look at CMT and say, like, I have this, 10 family members of mine have this, I know how to handle it, I know what to do, I'm not worried about having a child that has CMT. And other people will look at it and be like, I don't want to spend another generation who's have to think about having CMT and the difficulties that it causes. Both of these are valid. And so it is very much a personal decision between you and your partner or whomever it is that will be making a choice to have children. If someone chooses to pursue family planning options, there are two categories. There are prenatal testing and there is preconception testing. So prenatal testing is chorionic villus sampling, or CVS, and amniocentesis. And preconception testing is pre-implantation genetic testing, monogenic, which gets done with IVF. So the CVS and the amniocentesis both occur while a woman is pregnant, or while a person is pregnant. And in both cases, they take a sample from the pregnancy. So in CVS, they take a sample from the placenta, and in amniocentesis, they take a sample from the fluid that surrounds the pregnancy. In both cases, they are able to draw out cells that are from the pregnancy and then can analyze them to see whether or not the pregnancy is affected with CMT. The implications of that would be either the option for a termination of a pregnancy or for knowing a little bit more information post-birth about what to expect for that child in the future. Pre-implantation genetic testing monogenic, or PGTM, is done, as I said, with IVF, or in vitro fertilization. So in vitro fertilization is when sperm and egg are combined in a petri dish in a laboratory, and they are grown until they make embryos. And then the embryos are then grown until they have reached a stage where the part that becomes the placenta has been differentiated from the part that becomes the fetus. And they take a biopsy from the part that becomes the placenta. And they can then they freeze down the embryos, and then they analyze the cells that came from the embryos, and they can see which ones of them actually have the mutation that's in the family. And then they would take the ones that do not have the mutation and implant them into the womb to bring to term, versus the other ones would not be used. The ones that did have the mutation would not be used. And then this can then hopefully lead to a child that does not have CMT. The major downside to, there's a lot of downside. Some of the major downsides to IVF would be the cost is kind of the biggest one. So that I think it differs around the country, but in Stanford, you're probably looking at $30,000 to $100,000 to complete the process. And often it is not covered by insurance. There may be some plans that cover pieces of it. So it's a hefty upfront cost. There are a lot of steps that need to go through to see if it actually can be done. There's some people that they're not able to even set up the testing because they can't test for the specific condition or the specific mutation. And so there's some people that aren't even eligible for getting PGT. And sometimes the cell or the embryos that are identified as not having the condition that's being looked for are then found to be chromosomally abnormal. So they don't have that 46 chromosomes, or they're in the wrong order, or they look wrong. In which case, then you have to make the decision about implanting a chromosomally abnormal embryo, or using one of the embryos that does have CMT, or just rolling the dice and going back to that 50-50 chance and seeing if there's a chance to have a child without CMT. And of course, having a child through IVF is not quite as fun or sexy as the way that it happens naturally. In terms of downsides to genetic testing, or why wouldn't you do it? I mean, the biggest one is this first one here. It's not going to change treatment. It's not going to change management. Nothing is going to be changed today based on those results. It may be that will change in the future. It might be even a year or two down the line that there will be some kind of genetically based treatment, or a treatment that is based on, that is influenced by somebody's form of CMT. But in that case, you can get genetic testing at that time, or just for that one form of CMT to see if you have it. You don't need a test for everything. It's not going to change anything at this point. The variants of uncertain significance are frustrating, and they are confusing. So like I've had people that have gotten like 5 variants of uncertain significance, and they'll say, but how can you say that all of these added together don't give me CMT? And I will say that in genetics, we never say never, but that just isn't the way that we think that CMT is caused. It's not one of these multi-gene combinations that end up causing CMT. And so really, if you're getting a bunch of answers that are big question marks, how comfortable are you with the unknown? And if the answer to that is not, then it's not going to be a good idea to do testing. The interpretation of results is really important, because I already said something about how I get these variants of uncertain significance in recessive genes all the time. And I can't tell you the number of people that I have seen in CMT clinic who have come in with a variant of uncertain significance in a recessive gene, and their provider had told them that this is the cause of their CMT. And I have to take away diagnoses. And so having a person who knows a little bit about not just genetics, but CMT genetics is really helpful in terms of figuring out answers. And if you don't have that person in your toolbox, then it might not be the best person to do your genetic testing. There really can be an emotional impact with positive or negative test results. There's one thing to say, like, obviously there's something going on. I know that I have something happening. And it's another thing to get a piece of paper that says you have CMT. And this is the cause, and this is the genetics behind it. And so I don't want to, I want to just say, like, that is actually an emotional thing. And so a lot of times people think, it's okay, I know what to expect, I know what I'm going to get, but when it actually happens, it's different. And negative test results are, again, frustrating. And this kind of goes both ways, both in the like, I don't have an answer, but there could be people who have a family history of a known form of CMT, and they are getting predictive testing for that form of CMT. And if they get a negative result, it means they don't have CMT. And people can get a lot of survivor's guilt in that situation where they're like, why didn't I get it? Why did my family have to suffer through this and I don't? How is that fair? So that there ends up being quite a bit of an emotional side of things. There may not be a genetic test available. As I said, there's going to be another 100 genes that will be found before everybody with CMT ends up having a diagnosis. So you might not get an answer. And I put this genetic discrimination here because I think that people think about it, but I also don't think it's that big of a deal. For people who are affected with CMT, then they already have that in their chart, and getting a genetic answer doesn't change anything. It is a little bit different for people who don't have it in their chart. So like if you don't have a diagnosis already, then getting a genetic test that is positive would give you a new diagnosis in a pre-existing condition. Again, pre-existing conditions seem to have not been a big deal. I'm not really worried about health insurance or about job employment status. Those things have federal protections against discrimination. What doesn't have protection would be life insurance, long-term care insurance, and long-term disability insurances. So if a person was thinking that they would want one of those things and isn't having any symptoms and doesn't have CMT in their chart, then they should get those things set up prior to pursuing any testing. I'll just take 1 minute here and just mention that 23andMe, Ancestry.com do not cover CMT genes. So if you are trying to use 23andMe to find out your genetic information kind of off the books, it is not going to be the best way to figure that out. And taking the raw data and dumping it into a third-party site to do analysis is fraught with difficulty and challenges. And still, if something was found, would need to be confirmed in a CLIA-certified laboratory. And there's been just numerous examples of inconsistencies in analyzing the genetic data between the different companies and between the direct-to-consumer testing platforms and the commercial testing platforms. So if you want to do 23andMe for fun, for traits, whatever, that's fine. But I would not use it as a CMT testing platform. And same with Ancestry.com. They don't even claim to do health data. They're just kind of looking for your background, which again is fun. But it isn't going to do anything to you from the CMT point of view. So what's my point? Why do testing? Is this the right thing to do? Who should get it? Who should not get it? Well, you tell me. Do you want testing? Why? Why not? For this poll, you can actually choose 3 answers. So you might tell me yes to get a diagnosis, but no, I've had kids and I don't need this uncertainty. So you can do both. It won't change my management. I'm seeing some yes to get a specific diagnosis, and yes to allow family members to know more, and yes for family planning, and yes for community building, and yes to participate in research. And then just a little bit of no, it won't change management, and no other family members did the testing, so I don't need to. And I think I think all of your points are valid. All of you make great points, and it is really up to you whether or not this is something that you want to pursue. Just important you go into it knowing the answer. Apparently this poll is full. I've never seen it before. So it looks like most everyone wants testing, and I think that's fine. All right, I do believe that is the end of everything I had planned to talk about. I'm going to see if I can end this.
Okay, I am back with you, my friend.
Hello, Jonah.
We have a bunch of questions and we have literally 4 minutes left. So we will not get to, no, you're fine. We won't get to everyone's questions. And we knew that with most of the sessions, but I want everyone to understand that if we don't get to your question, please feel free to shoot it our way at info@cmtausa.org. I will put that in the chat right now. And we will get your question answered, I promise. And you can always go and meet with a genetic counselor anytime in your area. But Carly, a couple, I guess, let's just run through a few general ones and you can give your 2 cents answer. I think you covered why should we get tested. Dominant inheritance, you could have all your children unaffected. Is that the case?
Absolutely. 50-50 shot in every pregnancy, and your previous pregnancies do not influence what your future pregnancies will have.
Okay. How about which genetic testing lab are you using most commonly? Are there ones that you recommend, and so on?
I use a bunch of different companies. So I don't know. Am I allowed to say that, Jonah?
Sure.
Okay. So I use probably most commonly Invitae, and they do have a sponsored testing program, which allows for people to get neuropathy testing at no cost. And then I use Prevention Genetics quite a bit for both exome and genome testing, and I use GeneDx also for exome testing.
One question is, would love to have a chance to find out more about exome sequencing. Panel tests revealed nothing. Mm-hmm. How would someone go about that?
You have to talk to your provider about doing exome testing. It's more involved. There's a lot more to it. So it's instead of looking at 100 genes, it's looking at 5,000 genes. And so there's a lot more nuance in terms of figuring out the variants and if they're actually disease causing or not disease causing. And so we often get multiple family members involved in the testing. But it's quite a bit more expensive also. And so your insurance would have to be something that would be on board with it. So I use Prevention Genetics a lot because I love them for exome testing. The way that they do it is they have lab directors are assigned to particular genes. So those lab directors just are experts on that gene, as opposed to having to know everything, and no one knows everything. And so I just really appreciate that thought process of the way that they do it. But they also put their prices right online. So having one person in the family who's being tested is $1,890 for exome. And then if you include the parents, but the parents don't want to report, which is normal, then it's $1,990. So it's not cheap. I mean, it's funny because it's one of the cheapest and it's not cheap.
Cheapest. So is it fair, Carly, to say, because I know Dr. Chai has said this to me a few times, that someone who's questioning why get tested or not, for the research side of the CMT cure, it's helpful for the researchers to know the numbers of how many people have specific kinds of CMT, or no?
I mean, I think it is helpful for the researchers, but I don't think that's a reason to do the testing. I think that if it's going to cost you $2,000 out of pocket, but you're helping the researchers, that doesn't seem like a fair deal. So I think it is something that has to be more internal.
Or personal.
Yeah, exactly.
Awesome.
Do you actually care about this information? If you don't, why do it?
Could a variant of uncertain significance be related to the age of symptom onset?
Variants of uncertain significance are of uncertain significance.
Yeah. Is there a voluntary database for VUS genes where people can post their symptoms and compare to see if similar symptoms are associated with that particular VUS gene mutation?
I don't know the answer to that. There's Gene Matcher, but I don't know if that is if that is patient input or if that is provider input.
So again, everyone, time is up. Sorry, but we want to thank Carly for her time and you guys for your amazing questions. Send them to info@ if you have any other questions that did not get answered here, we will always hunt down the answer for you. I'm the one that answers those, so I can speak to that directly. Carly, this was wonderful. Just thank you for your time and for your passion for our struggle.
Welcome. Thanks everybody for tuning in.
Good job, everyone.